Vectorcast, what it provides. So that was more on the dynamic analysis. Yeah. So in during testing, we have come across static analysis and dynamic analysis, right? So I remember in my initial days of the job, so I used to do code reviews. Yeah, so it was really a hectic job. Like you look into the standards, yeah, and then you check the uh, whether the code has been written correctly or not. Yeah, against some standards. So now the life has become easy that we have tools to do this static analysis. Yeah. So why we need static analysis? So basically, uh, as the we have been saying during these previous sessions, as we test as early as possible, we try to get fix the bugs. Yeah. So dynamic analysis is one thing where once we write the test, only we will be able to check whether our we have met the requirements or not, and if our software is behaving as per our expectation. But as we start developing the code, yeah, then we need to check whether are we following the correct coding standards, yeah, are we following all the rules, and are we following the correct are there any errors, or like say divide by zero by unintentionally, if we have written anything, or if we are using any null pointers, something like that. So if these bugs or anomalies go undetected, yeah, during the development phase or during testing, so as the time progresses and we are in, say, suppose the later stages of development or during testing, it takes a lot of time to fix these issues, yeah, and the cost will also be increased. So what is the way forward? We bring the testing methods as early as possible, like forward towards the development phase. Yeah. So that's where we have the static analysis come into picture. Yeah. So as we understand the name itself, the static analysis, we are doing the analysis of the code statically, like without executing the code. Yeah. So in the previous session, we saw that we have done using the dynamic analysis, where the Vectorcast provides a solution for the dynamic analysis. Yeah. Now Vector has a solution for the static analysis. The product is called PCLint Plus. Yeah. So I think there are different static analysis tools available in market. Yeah, this is one of the tool which is what Vector provides. Yeah. So coming to the static analysis, so PCLint Plus was previously known as PCLint. Now the newer version is called the PCLint Plus. Okay. So so as we discussed, so these are the topics agenda what we will be discussing today. So understanding the static analysis, yeah. Then about what is PCLint Plus, then how we can integrate into different IDEs, or what is the method, the compiler configuration, why we need compiler configuration, how we are going to execute, when we have the PCLint Plus, then what is the output of the PCLint Plus, yeah. Then some demo notes, what we'll be discussing, then how we can, put this, once we have the diagnostic messages, how you going to present that, yeah. Then the help and troubleshooting. So in this session, we'll be more going into the depth of the tool, yeah. We'll try to understand more about the tool and its features, yeah. We'll talk about the features also about this tool, because there are a lot of competitors. It becomes important for us to know more what this tool does, yeah. Let's get into it. Yeah. So what is static analysis? As we spoke about now. So it's usually performed on the source code statically. So where we are not executing any code. Yeah. So that is the basic the analogy on what the static analysis tool is built. Yeah. So it looks for the coding errors. Yeah. The misuse of the any coding violations has been done. Then the bugs are there that can be found easily with the help of static analysis tool. Now, traditionally, static analysis tool would automate the code inspection task. Yeah. So we used to have a set of engineers earlier where they would do the code inspection dedicatedly. The job was for them to look into the coding guidelines, yeah, then check the code against this set of guidelines. So that job has now been automated. Yeah. So it doesn't mean that those team members have become, their job has gone. No, it's not that way, because still it is relevant for them to, look into this, whether still those, whatever the tool gives the output, whether those have been needs to be addressed or not, those still needs to be, corrected or not. So now modern tools have come, so where they do runtime analysis, but again, runtime analysis is not something we are running the code, yeah, running the like test cases or anything like that, but it does do a runtime analysis, like to check different matrices by analyzing the source code, yeah, and possibly to detect the possible bugs or anything, any issues are there. Now coming to PCLint Plus, it's a solution from Vector. Now there was a static analysis tool. Now there was dynamic analysis tool, which is the VectorCast. Then we have the PCLint Plus. So it basically detects anomalies in C or C++ code. So PCLint Plus supports C or C++ predominantly. We do not support any other coding languages as of now. Yeah. So basically the need was to understand, uh, you know, uh, to see, how we can improvise the code, or how to minimize the cost of, fixing the bugs. So if we do it as early as possible during the development stages, yeah, of the V-cycle model. Now we have on the V-cycle model, on the left side we have the verification, on the right side we have the validation. So at the base we have the coding, yeah, coding phase. So if we start using this PCLint Plus or the static analysis tool at this stage, so the developers will be able to fix the code as early as possible and give at least good quality of code to the testing team. Yeah, so that is one of the main point where static analysis tool comes into picture. So it can detect different variety of anomalies. Yeah, so this could vary from buffer overflows, null pointer dereferences, incorrect use of APIs. See, these things can be found out during the testing phase, but what if they are found during the development stage itself? Yeah, so the lot of time is saved for the testing team. Yeah, then the time will be saved that can be utilized, or for other activities of the project. So, and coming to the next set of anomaly, what PCLint can detect is on the suspicious coding constructs. Yeah, like say you have different type of coding constructs, like for the loops. Yeah, all those coding constructs can be detected, and then deviations of coding guidelines. Yeah, basically PCLint supports MISRA C, C++, CERT-C, and ATOSAR. Yeah, so if you are trying to misutilize any coding, if we are violating any coding standards, yeah, definitely we have to adhere to the coding standards when we are coding, but it becomes mandatory to, even if we are not following all the rules, yeah, but we try to follow as much as possible to adhere to the coding standards. Yeah, but suppose if we miss out any of the rules, the tool will help us to identify these anomalies. Then coming to the violations of user defined metrics thresholds. Here is very interesting feature of this PCLint Plus is that we have different matrices, correct? In the when we code, like we tend to see the number of lines of codes, how much we can comment, yeah, how much part of the code can be commented, how much what would be the cyclomatic complexity, yeah. So we all look into these matrices, right? So so PCLint Plus provides these matrices to the user. Yeah. So now suppose if we want to restrict the code to be like optimal and have minimal complexity, and because if we have the complex cyclomatic complexity as near to 10 or something like that, that it can be termed as maintainable. If the code complexity goes on increasing, it becomes difficult to maintain. So with the help of these matrices, what we can do is we can control the quality of the code also. So PCLint Plus gives the matrices, different types of matrices, what we'll be seeing in later stages of the slides. Then with the help of these matrices, we can do a lot of queries, like in any tools, like you have a lot of data, and if you try to put different filters, yeah, the same method is used here in the form of queries. Okay, so with the help of these matrices, we can do queries, like say, I don't want to have more than one return statement in my function. Yeah, so I can formalize it with PCLint Plus with the help of queries and along with the metrics. So I can use this as a parameter to help my code to be of better quality. Uh, there might be some users who might be using PCLint. Yeah. So previously it was known as PCLint. Now the newer version is called the PCLint Plus. Some more details of this PCLint Plus. Yeah. So it can act on a more than one file, and we can work on a single file as well. So it is certified for IEC 61508 and ISO 26262. Yeah, and as I mentioned, it supports different coding standards. Yeah, and it is available for Windows, Linux, Mac OS, and it is secure. And because most of the time we tend to work on a network based one, and there are chances that it can be possibility that there's an intrusion. So since PCLint Plus works on offline method, there's a less chances that it is prone to any attacks or anything. So that is one of the advantage what we have with the PCLint Plus. So more about PCLint Plus. Yeah. So it is a simple tool. It's a binary executable. Yeah. It comes we can work on the command line as well. We can integrate on your IDEs or any of the visual tools which has the interfaces. Yeah. So as a standalone tool, it doesn't have any GUI available, but we can work on the command line, and it has a lot of options with the even if it is a command line. Yeah, so we can integrate this PCLint Plus on a variety of IDEs. So later stages, I'll be showing on how we can integrate onto the Vectorcast as well. So it consists to work on this PCLint Plus, basically what we need, a module, either source code, I can say, either .c file or CPP file is one of the input. So it has to understand what are the different parameters, correct, to work on this file. So I give the executable, I give my .c file as the input. Yeah, it has to work on this file, but it needs to know what other features or the arguments it needs to work on, like say whether you want to have some options to be enabled, yeah, or some coding guidelines to be followed or not. Yeah, so like this you want to suppress some header file information. So all these kind of things needs to be passed to PCLint Plus as a arguments. So either we can pass it individually, yeah, or with the help of some intermediate files. We call it as LNT files, lint files. Yeah. So this we will see again. So basically, typically invocation includes compiler configuration, user configuration, optional configurations for checking coding guidelines, and the project configuration. So we'll focus more on compiler configuration. And user configuration is something where user wants to extract some data from the from these matrices. So there we can specify this user configurations. Then come to the guidelines, coding guidelines. Like say if you want to use MISRA, any coding guidelines, or say AutoSAR, okay. So these can be specified. So project configuration is basically something we speak about the module, right? So we have a .c file or a set of .c files. Okay, so these are the project configurations. What will be passed to the PCLint Plus are some of the arguments. So here is a pictorial representation of the integration. So here we can see that, uh, yeah, okay, yeah, not sure. Okay, so here we can see that, uh, so there is a static analysis tool uh, option available. Yeah. So once we have this, it's okay. So once we have this drop-down option available, so if we get the configurations to be done, please back slide. Yeah. So once we have this, VectorCast, we can integrate this PCLint Plus into VectorCast. So it's not the only tool where we can integrate. We have different IDEs to be integrated, and it can be Eclipse based or Microchip, MPLAB X. Yeah, we have different IDEs where we can configure this PCLint Plus. There are simple set of guidelines available where we have to follow these steps, and it will be ready to use. But one of the important point is the what are the configurations what you want to configure, or say give inputs to this PCLint Plus. So that is the one of the important aspects that we'll look into it. Now, coming to the compiler configuration. Yeah. So why we need, what is compiler configuration? Now, whenever we are executing any file, yeah, so we know the where standard header files are present. Yeah, we don't have to explicitly mention it, but what is there for PCLint Plus to know, correct? Where it needs to find. So we need to provide that information to PCLint Plus, yeah, to understand how where it has to find those specific header files and what are the different options it needs to know before it works on the the module. So that is what we do as a part of compiler configuration. So here what we do is we have a simple utility called PCLP config, yeah, which is shipped along with the PCLint Plus. So we use this as the input and pass some of the arguments. Yeah. So where we give where what is the compiler, what we are looking at, and what is the where it is located. Yeah. So this, when we provide this information, the PCLint Plus gets to know, yeah, what are the system headers it needs to, or the compiler specific headers it needs to know, what are the size options it needs to know, what are the intrinsic functions it has to understand. So all these becomes part of the compiler configuration. So it's just a simple step, a 1 minute job, where we just give a compiler information and where it is located, the executable compiler executable is present, and we pass it as a inputs to the utility. So we have the compiler configurations generated for the PCLint Plus to use. Yeah. So as we can see here, so it's a utility to generate the compiler configuration. So it supports different compilers, so GCC and Clang derivatives, the Visual Studio, IAR, Kyle, Microchip Lab, Metaware, TI compilers, all can be supported. But if you have anything else apart from this listed, yeah, definitely there's a different options what we can select. Manually we can select and can generate this compiler configurations. And the manual, what it comes with PCLint Plus, it's a very well detailed manual where we can look into this, and user can just follow those steps and will be able to generate these compiler configuration files. Yeah. So when we generate this compiler configuration, what it looks like. So it generates two outputs, .h file and one LNT file. So here I have marked this co-gcc.h, co-gcc.lnt. So .lnt is the file, is my configuration file, what it has generated. So it contains where my library includes files are present, or what are the different files options are present. Here you can see that there are different size options for say maybe integer, what float or double. So all those size options have been specified, and you can see the include options. All those header files have been included. So once I have this compiler configuration done, so I will have these two input, outputs from the PC configuration. These will go as an input to PCLint Plus. Okay, so this becomes mandatory process for anyone to use, PCLint Plus. But if you are running on a trivial, file, a simple file, you need not have to have this compiler configuration files generated. Yeah, but otherwise this becomes a mandatory step. So how I'm going to execute this, PCLint Plus? So as I told, so I have to pass some arguments to the PCLint Plus, be it a single argument or multiple arguments. Here I can see one example. Yeah, PCLint PCLP64.exe. Then there is co-gcc.lnt. Okay, so that is a compiler configuration file what we generated in the previous step. Yeah, that becomes the most one of the important parameters. Every time when I'm passing some arguments, like say there is one example here, pclp.exe, then there is this plus e 9019 test1.c, then there is 9034 example.c. So how it going to work? So PCLint Plus always take the arguments from the left to right. Okay, so once I'm passing the arguments, yeah, it's going to consider those arguments as the to work on that particular module. Now in this example, if you see, for the test1.c, there is an argument called plus E9019. Yeah, it's going to consider only 9019, which is basically an diagnostic message, what it can work on that. Yeah, so if we see example.c, yeah, it has both the arguments coming from the left side, 9019 and 9034. Okay, so it will enable message for the test2 or the example.c will have both enabled for .c file. Okay, so if we see this example, yeah, we have the binary executable, then we have the configuration file. Okay, so what we have generated. So it's a user defined options file, intermediate file what we can configure, like be it for the matrix what we want to generate out of this example. Then there is the coding guidelines, what most of us will be interested to give one of the input as coding guidelines. Then there are some options. Yeah, deliberately this can be put in anywhere in this command, but this has to be before the module name. Yeah, so at the end I have the example.c as the the final module on which it has to work. Here you can see it always goes from left to right. Yeah, so it going to consider the configuration file, then the user, then the coding guidelines, then the some other options, then it going to work on the example.c file. Yeah, so once this is done, so what is the output coming out of PCLint Plus? It's basically the diagnostic messages. Yeah, so I need to know what are the different are there any errors in my code? Are there any warnings? Are there anything additional which I want more curious? The user wants to know, is my code following all the guidelines or not? Even though I have respected all the coding guidelines, I just want to cross verify whether whether it's being satisfied or not. So yeah, so the output of this will be in the form of diagnostic messages. Yeah, so there are different error messages which are very much critical for before we proceed we have to fix them. Then there are warning messages, then there are informational, then there are notes. So here you can see there are diagnostic messages. Yeah, each have a code specified against each of those diagnostic messages. Okay, now as per as we understand the criticality, error being the most highly critical one, is warning level is set to 1. Yeah, warning being at level 2, and then informational as at 3, and the notes at level 4. So user can easily ignore either can warnings, informational and notes, but the priority being for the errors. Yeah. So suppose if I am if I go back to one of the slides, yeah, here in this example, PCLP64 error message 9019. Yeah, so it's a informational or say diagnostic message. So what it means is, I have my code, source code. It has to check against that 9019 diagnostic message. Yeah. So it comes in this range, miscellaneous elective nodes. So I want my code, so now I have done everything, but I want my code to check only for this particular diagnostic message or error code or warning message, anything of that particular code. So user can customize this also. Like I don't want to check any of the rules for the header files. I just want to have work on my source code. Yeah, either on C or C++. I just want to work on those. So user can suppress those diagnostic messages coming out of header files also. So that is the beauty of this set of arguments what we pass here. Yeah. So there are different sections available here. As we can see, there are different ranges for mentioned for C or C++, but yeah, all can be based on the file system we use. We can the PCLint Plus will give us the diagnostic message information. Now, after considering all these inputs, how we are going to work on the PCLint Plus? Yeah, so we install the PCLint Plus because it's just a binary executable. So when we download it, we have the executable available. We have the license. So we have some Python packages to install, and then how we are going to as we saw, compiler configuration is one of the main step to generate the to pass one of the inputs to the PCLint Plus. Yeah. So these are commands what we use. So once that is being done, yeah. So at the step 3, you can see pclint.exe co-gcc-lnt example.c. So that is how I'm going to execute PCLint Plus on my module, passing one of the argument as co-gcc.lnt. Yeah. Now the compiler configuration is one thing. Now I want to support work on my coding guidelines. Yeah. So these are different coding guidelines what PCLint Plus supports. So we have MISRA C coding standards, MISRA C++, AutoSAR 17, AutoSAR 19, CERT C. So like this, we have different intermediate files against each of those. Yeah. So whenever we use this, by default there will be coding standard which will be set. Like if you want to change, we have the option to change that as well. So that can be again configured into user LNT file. Now this is how it looks like in the whatever these are all shipped along with the PCLint Plus. So we have all the intermediate files which these can be used as an input to PCLint Plus. Yeah. Now how it typically looks like. Now say I have this, say suppose I take AU MISRA 2.intermediate file, lint file, how it looks like. It has set of arguments what you basically pass on the to the PCLint Plus. So all these are combined in one particular file called intermediate file. So basically it's a text file which has certain set of rules. Here you can see plus E1 plus elib, then append MISRA rule 1.2, like that. It has this different set of rules. Here you can see at line number 65, error message 5125. So whenever it encounters this violation, MISRA rule 1.2, so it's going to emit this error message or say diagnostic message on my console. So that is what it means. Now if I want to suppress this, I don't want to this, I just use a hyphen instead of plus. So I'll use a minus symbol instead of plus symbol. So plus symbol means it's going to emit, hyphen means it's going to suppress that particular message. So like this we have different rules embedded in these intermediate files. So user can customize also, or we can club all these in one lint file. Like say I call each of these intermediate files from one particular intermediate file. Now, that is what I was speaking about, how I'm going to, suppress or enable different types of messages. I can work on globally at a functional level, at a file level, and at a different, I want to suppress particular, message from a particular function. We can all have these options available within that lint file. So we can just use the symbols plus or hyphen to do these actions. Now, here you can see that one of the example is that I'm running this PCLint plus on a example file. Yeah. Now it includes stdio.h. Yeah. Now I have not given as one of the input the configuration file, so it's going to throw me an error, unable to open include file stdio.h. Yeah. So here you can see the importance of the configuration file. So if I provide the configuration file as the input, it works fine. So it produces different messages, diagnostic messages. So which I'll again demonstrate on my in a couple of minutes. So once that is being done, here you can see it is so not so easy to read these messages where user cannot go back to this, or maybe if he wants to put it in a text file, we can just redirect into one text file and still read it. But it becomes uneasy to read this and understand what are the where on which line the error message is there, what is the diagnostic message, what it wants to indicate, so that we cannot easily read it. So for that purpose, what we have is we have different formats available. So either we can export into an CSV format or HTML format. So to do this job, we have the intermediate files as well. So if you see here, in this one, we have HTML, then XML. Yeah, we have these intermediate files as one of the inputs to be passed to the as the arguments. Yeah, when we are executing this PCLint plus. So once we have that, we can generate the output in a CSV format or an HTML format, which becomes easy for user to read. So with the help of CSV format, we can filter out the files what we want to work on, or based on the diagnostic message warning level, whether if it is a warning or error, we just filter out that particular severity level, and then we will have only work on those set of files. Yeah, HTML is a more representable way. Yeah. Then how do we if we get any issues or anything, so how we work on this? We have a reference manual. There are different options, n number of options available for a user to work on. Then there are common issues chapter, what we will look into that. And there are frequently asked questions like, say, PCLint plus doesn't automatically go through each of the subfolders of your source code. It cannot work on that way. So for that, what we have to do is we have to generate a project configuration file where we have some commands to extract all the files from each of the subdirectories. We just pass that as input to this PCLint plus, and that it works on those set of files. Yeah. So we will move on to the demo part. So before that, if we have any questions, we can take. Open the stdio.h. Yeah. Now what I will do is I'll just go to what I can do is in the same configuration. So what I'll do is I'll just go here. I'll just want to generate the configuration file. So I have a set of commands already. So here you can see that this is a Python file. What we are or say we can is a utility file where it can. This is the one which will help us to generate the configuration file, and this is the compiler. Yeah. So all GCC derivatives, compilers, we can use GCC as the argument, and where is my GCC compiler located, and what are the output files. So as I mentioned, sudo-gcc. Yeah. So basically we mention the compiler name in the lint file and the header file, what it has to generate. So I'll just use this as the argument to generate my configuration files. Yeah. So now I go back to this configuration. Without configuration, you can see these have been generated. Yeah. So I'll just copy it for the ease. Yeah. So if I look into this lint file, what it has different options. Yeah. Now I have different size options, different include. Yeah. So once I have this, now I go go back to this command line to execute and see if that works or not. Yeah. Still it doesn't work. Yeah. Because I need to provide the path of this header file into my LNT file. Yeah. Basically, I have generated this here. Yeah. So I have the same set of files generated. I'll just open it. Probably it is okay. Sorry. Okay, can't open this. Okay, it is on some other. So I need to generate it here. Yeah. So once I have this, yeah. So I have these files, configuration files. So now I work on this, and I give pclint as one of the input and work on this. Sorry, why it doesn't work this way. I'm just trying out in front of you. So this is a kind of, sometimes we face real-time options. That is really okay. I'm not sure if that is going to help me. No, it's not working out. This is how we are going to, generate the lint file. Yes. I think I have missed that as the argument. Yeah, exactly. Yes. So that has been talking about that. Yeah. So I think I missed that command. Yeah. Thank you for that. So I thought, when speaking, we try to miss out on some things. So now we can see that we have sort of lot of informational diagnostic messages with what we have generated. Yeah. Simple way used to see is them as put it in a CSV format. Yeah. So I can say that so this is how it looks like in a CSV format. It is for the user to to filter out and see. I can just filter out different diagnostic messages, or I can generate in an HTML format. So that is how it looks like. So here are not passed any of the MISRA coding guidelines as one of the inputs. Yeah. So if I want to pass as one of the arguments for the MISRA coding guidelines, so what I'll do is, so I'll just go here and pass. So here you can see in the MISRA, you can see in this folder. So I have the previous command. Then I'll just put it, and I just want to see MISRA coding guidelines against each of them. Yeah. So there's because n number of diagnostic messages are coming out, because it is including also the header files. Yeah. So here you can see against line number 42, information 765. So there's a MISRA rule 8.10 which is required. So what does this message means? Yeah. So I go to the manual. So what I'll do is I'll search for 765, what it says, 765. Yeah. So just click here. So what it says, external symbol could be made static. Yeah. So this is a general, detailed explanation as to why there is a informational message. So here you can see against each of the messages, the category has been marked against. Okay. So like this, we can look into this each of these, yeah, and we can understand what exactly is the diagnostic message means. Now say I don't want to say I want to suppress the header file diagnostic messages. Yeah. So what I'll do is, so there's different options available. So I'm going to use use equal to 1. So this is going to suppress the header file, the messages coming from the header messages. So this I have already generated. Here I can see a difference. Yeah. So there is a header file coming from the header file. Yeah. So on the right side you can see this was generated without suppressing the header file information. So on the left side you can see the messages have been suppressed coming from the header file. But we need to note that if there are some error messages, it's not going to suppress them. Yeah, it's only the warnings, the informational, and the notes. But here you can see there are different. There's an informational message. What it says is it's a header has been included. That is what PCLint Plus will give us the information. So that is how we are going to suppress header file informations. So all these actions can also be done on a CI/CD pipeline. What it is demonstrated on the previous session. So we can integrate PCLint Plus on the CI/CD pipeline. We can just trigger those, and we can generate the the diagnostic message reports. Also, what we can do with this PCLint Plus is to generate some metrics. Yeah. So we have been speaking about some metrics. Yeah. So here, what you can see here is, so I have generated a matrix information. So for each of the file, what it has been working on, so it generates different matrices. So this is basically helpful for when we are planning the activities, yeah, based on the like say if you want to pass on this information to the testing team, yeah. So the tester has to know how many number of test cases that can be designed with respect to that particular function or say particular module. Yeah, so those all can be understood with the help of different metrics, or say NPath, say cyclomatic complexity. Yeah, so we using this information, yeah, we can have the queries being written. Yeah, like say I don't want comment lines to be exceeding this much percentage in my code. Yeah, so I have like say 10 lines of code. I don't want more than 2 lines of comments to be present in that particular function. So I can do that with the help of queries using this matrix. Yeah, so that is the one of the feature, best features of PCLint Plus, along with the matrix which what it provides. So that was a brief, set of features what I wanted to discuss. Yeah. So if we have any questions, we can take it up.
I had one question.
Yeah.
How do I find delta? For example, if I have made changes in the file,
is to generate a set of report before making modification, and after making modification then compare. So but for that purpose you have VectorCast where it does the CBT, yeah, change based testing.
not testing.
Right. So other than that, it's that before modification and after modification metrics we can compare and do it. But PCLint Plus does not do it automatically.
It's a purely file-based system. It doesn't
Yes,
have the
yes, it's a
concept.
static one. So
Static, okay.
yeah, yeah.
Hi. Complete source code for analysis like
Yes,
project.
yes, we can do. On a complete project, we can do, or on individual file also we can do. Yes.
Okay.
Yeah.
And second one, we have any database where I can keep all the track of what are the issues are reported, which are not fixed, like a triage?
Yes, we can generate the report.
Mhm.
We can, export in a CSV file. We can have the user, put a comment against them that has been fixed or not. So we can have a maintain, global file where you can just export these information, diagnostic message report into onto your, any.
And do they have unique ID like today that defect is there, that issue is there, and tomorrow somebody has fixed it?
Yes.
So then
So definitely that error has been now fixed. So you will not see the same message in the next diagnostic report you're going to generate.
Oh, so we have to compare manually.
Compare, yeah. So basically it's, it cannot, since if you have fixed it, yeah, you cannot see that particular diagnostic message coming, when you
Okay.
generate the report. Yeah,
Thank you.
yeah.
Hi, I have a couple of questions. Like, do you have the GUI for this? Like, if whenever the
Option. So I just click on this, say PCLint Plus, yeah. It automatically pops up with some of the arguments what I need to pass, yeah. So once I do that, so what I'll do is I'll just click on do analyze on my particular source file. So I just have to click on this. So I have this. It's going to point out to me to the line where it is. This particular information or any diagnostic message is present. But as a standalone tool, it do with the line at what line the particular error or warning is present.
okay, so to use this, I have to integrate with any
Yeah,
other
you,
ID.
you can use if you don't have any IDE, it's a standalone tool where you can just export into a CSV file. You can map the 9 numbers and you can work on that. But otherwise, it doesn't come with its own GUI.
Okay. And other question is like, okay, I didn't see anywhere the justification part. If some of the rules I wanted to
Okay.
violate for the project perspective, and I wanted to justify it.
Yeah, you can see justification is come part of the user activity because PCLint Plus is just something which will give you the activity. Which
Yeah,
will
my
be taken
question here it is like, for example, I have a multiple configurations. I have 5 configurations, and that all 5 configurations have with the common part and then mutually exclusive informations.
up. Yeah, yeah.
So
Okay.
there I wanted to avoid the multiple justifications for each
Yeah,
configuration.
see when we are generating the configuration file, configuration 1, yeah, and you have multiple configurations like 1, 2, 3, 4. Now you want to justify for the other configurations like 2, 3, 4 what you are not working on currently, correct? So you have set of diagnostic messages for configuration 1, or what you can do is you generate a configuration file for all the 4 configurations at once and you run your code. Yeah, it's going to execute on all those configurations. So you have all the set of diagnostic messages in one place for all the 4 configurations. So you don't have to repeat the justification for the missing configuration, anything like that. Does that answer your query?
Yeah, and my main question is like, if I have one configuration, right? If I
Yes.
justified 100,
Other, yeah.
then I should not, those justifications should not come in other.
Yeah, because see, the thing is, since it's static analysis tool, now you have working on some particular configuration, you are generating a particular report. It's going to generate the diagnostic message for those set of set of rules or the violations what it has. Now, if you are working on configuration 2, you will generate again set of some rules. Yeah, so it becomes again the user. It depends on the user. They want to club those or just refer the previous justifications or something like that.
Okay.
Yeah.
And how are you addressing this CWE for this, like this common weakness for cyber security?
Since it's an offline tool, yeah.
Okay.
So we don't have anything, something with related to cyber security on that.
My last question is like, currently we are using the police space, like
Okay.
how exactly, like what makes me to go for the PC link?
Yeah, maybe what you can do is take a evaluation license from us. So you work on that, so that will help you know to understand the new features of but certainly I cannot comment on what tool you are using, but
No, no,
but
I
can-
mean like, are there any additional, like you might
Yeah.
have done studied, right? Like, is there any additional things? apart
no,
from
we have not studied the other tools, but we focus mainly on PC Lane Plus. So if you want to explore the things, you definitely we can help you with that. Yeah.
that? Okay, thank you.
Feature. For example, I'll tell you the scenario. Say I'm implementing
Okay.
and I need to cater to CERT C or MISRA C coding guidelines.
Okay.
And while implementing, is there any tool or feature or plugin which will tell me, okay, whatever statement or condition I've implemented does not satisfy the CERT C or MISRA C guidelines? I think it's called a dynamic analysis only.
Yeah. See, the thing is like
It's basically the guideline misses.
guidelines. Yeah, certainly we can pass those inputs. We have spoken about these coding guidelines, right, as one of the inputs. If you just see here what it supports. Yeah, here you can see you can pass one of these inputs as arguments. Like this will tell you whether we have violated which rule. So that is what exactly.
So these arguments, see, basically I use software ID GHS.
Okay.
So how do I integrate?
So we just pass this as one of the argument to the when we are configuring PCLint Plus. That is the simplest option. So I'll just tell you, I have integrated this in VectorCast. Yeah. So if I want to integrate VectorCast, I need to pass some arguments to PCLint Plus also. Yeah. So here you can see that this one arguments to VectorCast. So here is the PCLint Plus executable. So here is the configuration file. Yeah. And here is the MISRA lint file as the optional file. So here I can list more than one intermediate file as one of the inputs when you are configuring for your IDE.
Correct, sir. Whatever statement or condition you implemented does not.
No, it doesn't pop up, but you just have to run that
Run it.
tool on that particular file.
Yeah, again, it becomes a static analysis tool. Only.
Yes,
It's
yes.
not dynamic.
Dynamic is something you want to run the test cases on your code.
No,
So
actually.
dynamically, okay, you mean to say as you go on writing the code, it
Yes,
should pop
yes,
up.
yes,
No,
yes.
no, sorry.
In one of the, I mean, it's not a vector tool. In one
Okay.
of the tools which we use, not exactly the same coding guidelines. There's
Okay.
some other proprietary coding guidelines. It will pop up and show, okay, you're missing the guideline.
Okay.
So, is there any tool which Vector provides?
So before you start with the dynamic analysis, you need to know what are the problems happened in the source code. So you run through the static analysis rules, what are the MISRA guidelines you missed. So I'll fix that first before I start the dynamic analysis. Yeah. So that's where the PCLint Plus comes in. So you run these the lint file, what he
correct.
said.
I'll have to run my PCLint Plus to
PCLint
find out
Plus,
my
and you
warning
get the
misses.
warnings, errors, what are the
Yeah,
different
correct.
options there. You fix it and you come to the dynamic analysis.
Correct.
We can't just make it with the static analysis as a dynamic analysis tool. The PCLint Plus.
Yeah,
actually.
correct. I understand that. But what I'm asking is there any
No.
other tool or a plugin
No.
which Vector provides which will help me while implementation only?
No.
It will just give an information. A user need to do it. We don't have any of that sort.
Yeah, we don't
We'll,
have.
we'll discuss more.
Yeah, I think.
Yeah, thank you. Understood.
No issues. Yes.
Okay, that this I'm not going to fix. So this is my justification.
Yes.
But for next baseline, when I
Yeah.
rerun this diagnosis,
Yes, yes.
then in that case, do I can I retain that justification again, or do I have to justify again?
So you can still refer, it becomes part of the project process. So how you want to, justify those warnings. Like say, I can still refer the previous baseline justifications in the current baseline.
Okay.
So we can still use that.
But
But
through-
within this, we don't have it. Because when we run that particular code, it's going to generate for that particular baseline. Because it cannot, dynamically induce that this has already been justified. Yeah, it cannot cater into that.
Okay, so manually I have to take care that
Yeah,
same
it has to
justification I
be
have to
taken
find.
care with that. Yes, yes.
Okay, so tool doesn't provide that.
No,
key.
doesn't have option to take the justification from previous and that has been addressed. So I should suppress that here. So what, in other way, what you can do is, since if we have already justified those particular warnings or say error messages, when you are generating this on the new baseline, you can suppress those messages in the intermediate file, LNT file. So I was showing you this intermediate file, right? Say that, not here. So in the PPT, I was just showing you this. Sorry. Yeah, here. So here you can suppress those warnings or error messages that you don't want. So now you have list of the warning message numbers. You just search that in the LNT file. You just put a hyphen symbol against that. So it's going to suppress for you.
So that warning will be suppressed across
For
all
your
the code.
that, if you have already given justification, so in the new version, you will not have those messages
Okay.
listed. So that way you can have a workaround for that.
Okay, okay. Yeah, thank you.
Yeah, no issues.
We have one in the end. Hello. So all the files which are under analysis, this.
Yes, yes.
Now, if I want to do for selectively some specific files, so I remember there was option e-file, something was available,
yes,
right?
yes.
Likewise, we also have for e-functions.
Yes,
can
we have that, yes. Queries.
But if you are suppressing, like for the problem narrated by the previous person, maybe the problem was there in a specific line of the
Yeah,
code which
yeah.
he want to suppress.
Yes.
But now with this solution, you're suppressing everywhere in
Yeah,
the file,
it's,
right?
it's basically the user has to take care whether they really want to suppress those set of messages or not. Because I don't want to have, suppressed in all other files, but I'm expecting something out of those files, some error messages or warning messages. So that user has to take care, consciously, or we can just exclude those set of files where we don't want, this rule to apply. So I just rerun those, set of files again with these messages, being, popped up, with
Okay.
plus.
Now, if I have my ecosystem, I'm bit familiarity with the PC lint.
Okay, okay.
Now, if we want to develop with the multiple file, because example is all about one file.
Yes.
We always have seen the examples in the demonstration. It's a very
No
simple
issue.
one.
Yeah, no issues.
Okay. Keeping multiple files in place and then giving multiple lint files.
Yes.
One lint file is a generic options and one is specific to a file. What would be the order? What final option will be used for a specific files?
Yeah, you can define the order, say .lnt, yeah. Then I have one more, my user one, yeah, .lnt. So I can go on adding these, lint files and make this one as the one lint file. So I just pass this as the one argument in my final command. So it's going to take this aumishra.lint, then user, then it's going to take that order.
Okay, so this top level file will list down what is the order, or you're mentioning. I somehow I lost.
Okay,
this
sorry.
thing.
Okay, I'll just save this file
Yes.
as say on the is my say final.lnt.
Okay.
Yeah. So I pass this final lnt as the argument in my command line for
Okay.
my analysis. Yeah.
Okay, so
Instead
you
of
include-
lint example, I just give final lnt as the parameter,
Okay.
where final lnt will have my aumishra.lnt user lnt. Then I have my project specific .lnt file. This will have my all .c files as the inputs.
Okay.
So this I can do it with the help of single lnt file, where it lists again some lnt files.
Okay.
Yeah. So this I can do it. Yes.
Okay. Thank you.
Yeah.
Generated codes.
Yes, it just works on any .c file or CPP file.
Yeah, usually because in most of the
Yes.
cases, whenever
have-
we have a auto code, it gives you a warning, but finally we don't know how to handle those things. So how,
Yes, yes.
how is this handled in by
It
this
is,
tool?
you just have to pass that as the argument to PCLint Plus, so it just works on in the similar fashion, the whatever you have generated the code.
Lint example.c, what he has done, it's an input to that. It doesn't matter whether it's auto-generated or handwritten
manual,
code.
yeah.
So it just lists down all the information or warnings or errors in the PCLint Plus tool.
Okay, thanks.
Okay, so thank you, Prasanna, for the insightful session. So now
Thank
we
you,
break. Now we break for lunch, and we'll be back at 2 o'clock. So
and how it is increasing in the source code. Okay, ultimately whatever is the technical depth, it flows down to the source code level, correct? So when you flow down to the source code level, at the implementation level, okay, so this becomes a very challenge, okay, in order to fix this technical depth. Okay, so why this technical depth will happen generally? Okay, the software being non-critical initially, and now the software is being critical. Okay, so why this critical levels being introduced here? So we follow, I mean, like generally the industry standards follow, and the safety critical systems come into the picture. Whenever the safety critical comes into the picture, so you may have to change your source code, and the source code will not be actually valid. Okay, not valid in the sense like you may have to, yeah, you may have to adapt to the time, right? Whenever the time goes, this is the graph actually. So how the code quality is being affected with the time, right? So so what we need to do in order to reduce the technical debt, right? So when you want to reduce the technical debt, you have to refactor, as our colleague said. Okay, so how does this refactoring helps? Yeah, so when you continuously refactor the source code, and when you run the test cases, okay, so we can able to reduce some technical debt, right? So there is some challenge in refactoring the code. Generally, the developers may think like they may be breaking the source code. Okay, they may break the functionality which is integrated in the modules. Okay, so which is interdependent. Okay, so when you go here, generally the refactoring requires we have to identify when the refactoring is required. Okay, when you look at the quality matrix and identify there is a requirement of refactoring the source code. Okay, and so we have to baseline the source code. Okay, so after baselining the source code, we can have a modification of the source code on the baseline code if it is necessary. Okay, then we quickly do the change-based testing. So this is a cycle where it helps the developers as well to quickly create the automated test cases and automated test harness in the VectorCast. All right. So when they see the source code has been changed and the change-based test cases have been run and there is no impact, then they can again get the quality metrics. Correct? And when they look at the quality metrics, if they again want to refactor the code, okay, then they can go for refactoring. Okay, so there is an advantage of the automated test cases, which helps the developers as well, which they can do a sanity check between the source code functional modules. Okay, so when the functional modules are are intact, then they can do a baselining of the code. So this helps in continued development and refactoring the source code. Right? So how does the change-based testing works here? Okay, there is a huge chunk of files, source code files. Okay, and the baselining has been done, but they identified they have to do the refactoring of the source code. All right. So they have done some refactoring, and VectorCast identifies the changes have been detected. So VectorCast can identify which file is being changed. Okay, so you have a chunk of files, only some part of the functions have been changed, right? So this is the file level. This is the file level view, and in the file level view, you can have the functional level view also. Okay, which part of the test case has to be re-executed, and it is not failing. Yeah. So the affected test contents are also listed on the result window. So what are the test cases have been executed? All right. And how many test cases have been executed? What is the functional level test case are executed, and you can get even the source code coverage for those. Okay. Yeah. So we need to capture the metrics, right? So we can measure the code coverage. So based on the code coverage, we can actually decide there is some problem, there is some deficiency in the source test cases. Okay. So in order to cover the deficiency, we need to have, so ultimately there is a source code change, and we need to have some test cases to cover the source code, correct? So which vector cast will identify the source code, there is a deficiency in the source code, and we can add the test case there, and we can fulfill the coverage. Okay. And yeah. So I think you might be seeing this this picture from the morning. Okay. So, but we will integrate our vector cast with the continuous integration server, and as well as our test insights, which is one of the feature with vector cast. So what does the test insights do will be discussed in the next slides. Okay. So traditionally, the continuous integration server will actually, the developers push the data to the CI/CD, and they will build the the source code, they'll test it, and they accept or reject based upon the test results. So how do they monitor based upon the quality dashboards, correct? So when we integrate the vector cast in between, okay, so the developers can run the vector cast, okay, in the change-based testing view. Okay, they can run the change-based testing on the changed source code or the refactored source code. Okay, and vector cache can push the test results to the web application, okay, which is called as test insights, where the real-time KPIs will be captured, okay, in the graphical view. Okay. So a tool pushing the test case data to the web application will be visible to all team members, including developers, testers, as well as team managers. Okay. So the test insights includes a role-based access system, okay, where the users or the owners in the sense those who created the team area. So the more we'll be discussing in the next slides. Yes. So here, when you come to the slide, we have the account service, where vector team services comes into the picture. Okay. Now we have a team area. Okay. If you carefully observe here, there is a cloud here, right? So the cloud indicates you are connecting the people. Okay. So the vector cache will be installed on all the systems. Okay. Like developers, testers, and as well as, okay, the testers, and they can capture the real-time KPIs also. The moment they connect to the cloud, all the team area members can view based upon the role-based system. Okay. And each of the user, they need to create the project. I mean, they need to create a test object. The test object contains like integration level testing, unit level testing, maybe system level testing as well. So all the different levels of testing in view model can be viewed on the test insights window. Okay. So if you see here, you can create a multiple team areas, right, based upon the levels of testing you are performing. Okay? So you can have independency between these two areas. Okay? Even the developers can see the code quality as well. Okay? The code quality metrics also can be seen by the developers without talking to the testers. Right? This is one of the biggest advantages. Okay? And you have independency here. Okay? Generally, in some industries, you will have to maintain the independency with the testers, developers, code quality experts, right? QA engineers. So here you will have that advantage. Now coming to this slide, so we will discuss like how the test insight works here. Generally, we have a web application, test insight web application, which is integrated with the vector team services. So you will have an account and vector team services, which is integrated with test insights, and you can use either of the web interface or you can use the command line interface. Okay. When you talk about the command line interface, we provide some separate application in the vector team services itself. Okay. The simplest method to push the data is through SCM. SCM connection services is available in the test insights window itself. Okay. So where you will push the data through the vector cast. Okay, single button click, all your metrics will be on the web application. Okay. So along with this, as we discussed in the previous slide, along with the vector team services, how the accounts are managed regarding the RBAC, role-based access control systems. Okay. You can also have a user-defined role, okay, where a new team area can be created, deleted, edited, and if you want, only a team member can push the data, only the quality metrics, okay, where you can clearly see, you can create a new defined user roles and give the special kind of privileges to the corresponding user. So for this, first an account service operator has to send a special request to the mail ID. Their mail ID has to be known and they have to send the invitation to this user, where the user has to accept the invitation and that's all. They are integrated to vector team services with the SCM connection service. Okay. So this is how the test insights window looks. Okay. I think we will scroll down this page in the demo session. So where you have function level coverage, statement levels, okay, and you can also map your requirements here, okay, and you can see which test case connects which requirement. When you integrate it, okay, with RGW, that means requirement gateway window. So we have different requirement gateways like Polarian, Codebeamer, IBM Rational Doors, okay. So we can integrate with different kinds of requirement gateway tools, requirement tools, where there is a structural traceability. So where you can understand which test case is covering what requirement in the test insights user window. Okay. So here, the top corner you looks like test insights, projects, overview, coverage, test results, and code quality. So you can navigate between these tabs and get the details. So currently we are looking at the test results tab. So where it looks how many results are failure, what are the pass rate, and you have a pie chart where you can graphically communicate with the team members as well as managers as well as the developers, and looks which test case is getting failed and what is the requirement to it, associated to it, and what is the code associated to it. When you map the requirement of the source code, so you can easily identify which test case is failing and why it is failing. Okay. Yeah. So this test insights code view window, when you connect with GitHub, you will get the code window, which part of the test case has been covered in green lines, and what is the what are the additional test cases you need to add for this part of the else condition. Okay, so this happens when you connect through the SCM server with Git. Okay, this is one of the club identified areas where you can see multiple hit areas. Okay, you can drill down what are the source code which is not covered. Okay, and this is the graphical representation where you can see what is the test case covered, what are the coverage levels achieved, complexities, cyclometric complexities in the test insights window, where we will see in the our demo session. Okay. So these are the couple of real-time quantitative metrics which will help us to decide whether the refactoring of the code, okay, is a good, I mean, like whatever the refactor of the code has been done is we can measure with this quality metrics, okay, and you can assess how the quality is there with the source code, how good the quality is there, and you can also analyze the trends, okay, in the graphical view. So, and you can also calculate the complexities as I said before. Okay. Okay, these are the couple of real-time KPIs where you can minimize the technical debt. Okay, why technical debt can be minimized is like we follow the agile structure and we continuously develop the software, right? So when you nullify the one of the technical debt, the other one will be coming, unfortunately. Yeah? So now we will see the demo of CBT in VectorCast. Okay, this is the VectorCast window, how it looks. Okay, and I have created a demo event for our for our event. I have created one project here. So where I have created our tutorial project window. Okay, where I have added multiple files to the environment, and we can run the test cases. Okay, how we can run the test cases? See, if you see here, there are some .c files. Okay, these are the .c files: database, manager. Okay. Yeah. These are, and the red color looks like functions. These are functions. The red color are the functions, and these are the .c files. Okay. Now, with a single click, we'll create a automated test cases. That's it. The test cases are here. Okay. You can see these are the basis for test cases. Okay. You can still see how the test cases have been created by analyzing. Okay. V-analysis report. So what is the test case? How the test cases have been generated in the unit manager. Subprogram include desert. So what is the test case it has been added? You will get a clear view here. Okay. When you run the test case, so for time being, I'll just show what is the instrumentation level here. Okay. So our instrumentation level is statement plus branch. Okay. And when I do the update, yes. Okay. We'll just run the test cases now. Right click on it, execute the test cases. Okay. So here we got the coverage. When you look at the function level, file level coverage, you can see view coverage. Okay. So the green indicates the functions have been covered, statements plus branches. Okay. Now, we'll do a small change in the source code. Okay. We'll open the source. Okay. Just make it writable. we'll remove this part. Okay. Okay, so this part has been removed. You require to incremental rebuild. Okay, so this incremental rebuild will take the CBT, change-based testing. Okay, so where you want, so for here we are having only 4 files. It's okay, like we are taking some time, we can rebuild it. It will not take much time, but if you're having a large source code base, it will take some time, like half an hour, 45 minutes. Okay. So here there is an advantage of incremental rebuild. So what does this do? The only changed part will be built. The objects will be created only for that. Okay. Incremental rebuild completed, which is much faster. Okay. Now, okay, I'd like to show the changes on the source code. Okay, I'll just take another function here. Okay. Now we'll close the project. Okay. So if you see here, there is an exclamatory symbol here. Okay. Where there is a source code change happened. Okay. So here, if you see, we can still, this is the managed project where you can do incremental build. So you can only build, or you can build and execute incremental build. Okay. So this is the environment affected, and how many test cases are run? There are 5 test cases which are run. Okay. So this helps faster refactoring of the source code, and you can keep the modules intact. Okay. Now we'll come to the test insights, web application. Okay. I'll just quickly show how the UI looks like. Okay. So now this is the team configuration. So for this, you need to have the account registration. You need to do it. Okay, for the vector team services. Okay, so here you have the application called Test Insights. When you open it, okay. So I already have the project created here. Okay, we can go to the Insights window and see the statement coverage in the Test Insights window. No, 1 second. Push result data to the Test Insights window. Okay. Yeah. Okay. I think it is taking a bit of time to connect because of the bandwidth issue. Okay. So here, this is what the window gets opened, popped up. So here, what I need to give is the team area URL ID. We need to give it here. Okay, and connect to the team area. Okay, we just double sure whether the test team area is getting connected. Okay. Okay, so how the test insights will be working? There is a bandwidth issue at this place, at least. So I tried there. It was working fine. The bandwidth is a problem here. Okay, we can take at the demo counter. So this is how the CBT along with this vector cast works. Okay. Just try it. So, so when you go to this, I'll just open the test insights window. Okay. So here is the code coverage. Code coverage, you can able to see the code coverage. You can navigate between these windows, these tabs, yeah. These tabs, and you can able to get the overall coverage between the cross-functional teams. One second, my colleague is accompanying me to show the VectorCast test insights demo. Yeah. Okay. So. Okay. Here is the okay. So here, when you click on the test insights window, we just check the team area access here. Okay. When you check the team area access, test the team area access. So I am invited to my team area, my colleague to my team area, and he can able to push the data. Okay. And just click on OK. Okay. And here is the project where you want to push the data. Okay. Select the test object. So this is a test project where you can push the test data. All right. So here you can have integration level testing, unit level testing, as well as system level testing, as per the nomenclature. Okay. Select the test object and push it to this test area object, team area. Okay. See, these are the different levels of source code coverage. Okay. Whatever the coverage type we have. We have built our source code, we have selected here. So based upon that, these will be enabled. Okay. So this static functionals are getting updated. So currently it is being disabled. Okay. Now, just push on the button. Okay. Yeah. So now the push is happening here. So this is where how this totally depend on your bandwidth. So if you have a good bandwidth, the push will happen very fast. Okay. So now the push is done. Now we will go to the test insights window. Okay. Yes. So here is the what I was speaking. These are the projects. Okay. So this is where we push the data. This is from the I push my data from my laptop to this central web application server, and my colleague pushed to this test object to this application server, where you can see this is the code coverage. Okay, what is the included analysis function level wise, file wise, functions, statements, and coverage statements. You can scroll down and you can shift to the objects here. You can as well as shift it. Okay, based upon the integration level testing, as well as unit level testing. You can shift between the objects. All right, modify. There is no modify condition addition coverage. Okay, maybe we have enabled here. Okay, function. These are the test results, and these are the function metrics. So what is the function complexity? What is the so we have different levels of analysis on the complexity. Okay, this is regarding the overview, and when you go to the coverage wise, specifically, you will see what is the statement coverage. There is 100% statement coverage. When you click on this window, you have only one .c file here, right? And you can see statement coverage. You can see the function level coverage here. And when you open the function, okay, maybe this has to be connected to the SCM. Okay, this is to be integrated. Yeah. So this is coverage, and when you go to the test results, you have what is the pass levels. If something is happened abnormal and you cannot able to execute the test case, and it will be categorized as an error in the test system, so which will require special attention and to be fixed of the maybe build system. Okay, failure and incomplete test cases, like you have to add some test cases where the source code coverage branches have been not tested. Okay, so where CBT will help in identify which areas these non-conclusive part is there, and we can go to the specific function and add the test cases. Okay, so these are the number of test cases which have been executed on this manager.c file. Okay, and when you go function level wise and test case level wise, okay, and if you see here, there is a trace items window. So where we have traced our requirements through a CSV format. So we have CSV integration as well to the our vectorcast requirement tool. Okay, requirement management tool. So where we have tagged this requirement to this test case, particular test case, and we can able to see what is the coverage. I mean, like how much the requirement has been covered. Maybe if you tag in multiple requirements, it will take the requirement coverage. Okay. Now, so this is what at the test case level. Okay. So this is mainly about the test insights integration with the vectorcast, and we have command line interface where you can initiate the CBT with test insights as well. Okay. So there is an executable where you can initiate the CBT with the project level wise, and you can have only set of files to be executed when the change is detected in the test system. Okay, so that's all from my side with the demo point of view. Yeah. Yes, definitely.
Aggregate coverage. I mean, overall, what is the statement on the branch,
Yes.
MCDC?
So when you look at the project window, you have to go, so one test object contains multiple .c files which will be pushed, and you will see aggregate in the result window of the vectorcast, and which can also be seen on the test case test insights window as well.
Okay, thank
you. Of this tool so that we can evaluate for some time and then decide on this.
Okay, yeah, it is possible.
Test
so
insights.
with the vectorcast.
I mean both vectorcast along with the test insight.
Yeah, so that one you can we can discuss offline with our business development team, and you can proceed further.
But it's possible.
Yes.
I have a morning. I asked a question. The same. I'm going to repeat again. Like the generation of test cases. So this tool refers the source code.
Yeah.
But as per the process, like use the design with as input to create the test cases. So this is violation of the process. Like so, is there any possibility to if the design will can give as input for this, and from the design it will generate the test cases?
From actually the main input for the vector cache is the source. So ultimately the test cases will run on the build system and get the coverage report. So ultimately we need to instrument your source code to get the coverage. We need to have the quality metrics, KPIs, which has to be displayed so that you will be sure your source code is not broken anywhere.
Okay. So other one is like, is this covering the BVC cases, like like what level it will generate the test cases? Like so is it covering all the possible BVC cases?
Yeah, the automated test cases, when I shown the example, you can have the analysis of the basis part test cases, how the test cases have been generated, for which
has to be done after
you can generate the, I mean like how the vector cache generates, it will be listed on the result window. Please carry on.
I just want to add on it. Basically, automatic test case generations, generated test cases, the intention there is to test robustness of your software. And whatever the basis part test cases that VectorCast generates, VectorCast uses Edison Design Group parser. This is the same parser that is used in commercially popular compilers. So what VectorCast does is that it parses through your source code. It will understand what are the distinct parts the control can take, and what are the signatures of the functions, okay? And based on that, it can generate the test cases. And these automatic test cases, if you want to quickly test your software before releasing it, not understanding the complete logic of your software, then automatic test case, basis part test cases can help you there. You get some coverage, and at least you're confident that whatever the code that you have developed, at least some part of code you have done the sanity testing. Okay, that is one thing. MCDC test cases, based on the Boolean expressions that are present in your software, VectorCast will make sure that these MCDC conditions are covered automatically using automatic test cases. And we also have min-max test cases. VectorCast is intelligent enough to know that the sizes of the primitive data types like int, char, float, and based on that it can generate test cases. Again, test the boundary values, meaning we are testing the robustness of your software. Okay, so this is the motivation of having automatic test cases under the tool.
Okay. Okay, my last question is like the trace part we are telling, right? Like more we are talking the requirement tracing, like design to the unit test cases tracing, like how are you addressing that part?
We have to understand that VectorCast is a software testing automation tool. Okay. And on top of that, we are providing a capability to import the requirements into the tool and export back the pass-fail status. There is no way from the requirements tool can understand that it has to generate the test cases based on whatever requirements you have set at the top level. But it will help you in creating the test cases easily based on the requirements that you have. It has many facilities to make your experience seamless when it comes to testing.
Okay. Okay.
Adding our own test cases based on the requirement.
100%. That's what you can have your own test cases. You can have automatic test cases, and both can coexist.
Yeah. Apart from the automated test cases, you can also add manual test cases based upon your requirements.
Arun,
you
can
can
you just show
generate
it on the
test
tool?
cases.
Can you please show it on the tool?
Okay.
In a much simpler way, whatever he is explaining, default whatever functions that are coming external to your UUT, whatever unit is under test, are 100% stubbed. by Vectorcast. Nevertheless, you can cherry pick if you want to, but by the rules of unit testing, whatever the functions that are coming external to the unit under test, they are stubbed by default. Now, using SBF, Vectorcast will give you a provision to stub the functions within the same C file per test case basis. So you will have a context switching within the test case where you can also try and stub the functions coming from the same C file. So you are not only stubbing the functions which are external to your unit under test, you will also have a provision. You may use it, or you can use the real code to stub the functions in the same C file as well.
So, hello?
Yeah, please go ahead.
I have one more question. Is the license, I'm talking about the Vectorcast, is the license for Vectorcast for unit testing and for the tool for the continuous integration are two different licenses, or we can achieve using the same license? It's the same license.
Yeah,
if you are trying to access it in server mode, like you want it in headless mode, like you want it server licensing as well. There is something called there is something called like you want all the test cases to be automated and you don't want any intervention at all in your pipeline. Then there is headless license, server licensing model as well for that. That is for that particular.
Hello? Yeah. I'll just give a brief explanation of our test system. We have, similar to this Vectorcast, we have a test tool from a popular vendor. So that where the unit test runs. And then we have our system test environment. Basically, what we want is when the source code, new version is updated into SVN. So there should be, the system should be automated in such a way that they should check out from the SVN. The unit test should start automatically, and then the same source code should be used for, once the unit testing is completed, the same source code should be used for the automated system test execution. System test execution we are doing using the vector tools only, Vita Studio and Kanu. So we want to do that automation. So now in this scenario, how many types of licenses of Vectorcast do I require?
Okay. Individually, when the user is using in the desktop, when the person is working, he or she will need one license, and you are trying to automate it in server model, like you don't want any intervention, and you have certain regression tests kept aside, and you want the test to be executed after every build release. You are automating the entire system. So in that scenario, you are having Vita Studio for test management, Kanu test cases. Along with that, you have this regression tests as well. All that you have a separate package, and you want all of them to be executed overnight build. So in this scenario, you wanted to have headless license. There is one more provision called server licensing, where like parallel executions you want it to happen. Like you have multiple programs, like different variants, and you want it to be executed on multiple parallel execution cycles. So there is something called server licensing. Without any manual intervention, you can configure that, and that license will be specifically used for that, and it will be executed. So this is the model.
Yeah, server licensing meaning there will be one license, or one server license for this.
One execution, one license will be given for server. So that license will be consumed for that track.
That track. So if there's a second track, I need one more license, is it? Yes. That will be managed by one server.
Yes.
So basically, there will be one PC which will be managing all the licenses.
Server licensing is same as Kanu. How Kanu licensing? I think you are familiar with Kanu. How for server licensing alone? For server licensing alone, only for server licensing. This one specifically, just to give you little context. To keep it simple for you, I just said that.
What I understand is currently in our office, right? Currently, Vita Studio, we have multiple Vita Studio licenses. So there is one server.
I mean, Kanu doesn't have server licensing model. Each user is a separate user. Like if you want to use it in So, okay, ignore that Kanu part. I don't want to confuse you. There is something called server licensing model. Each track has separate license. And if you want to use multiple tracks for multiple programs, you have to take how many tracks you want to run parallelly, that
So
many
many licenses.
server licenses.
I mean, you were referring to the named user license, which we can.
You will be aware of what is actually happening with the.
Correct, correct. So
You understand fragmentation
You can take mine.
So you understand, right, Venkatesh, what is happening in our company? I think we are interacting closely with you.
correct.
So we test today, right? We have multiple licenses, and there is one machine which is controlling all these licenses.
Correct.
Right.
So basically,
Is
what
that
license?
what you call as server licensing?
No, no, that's not the server license. So basically, whatever you had purchased initially was a device license, what we call. And since there was a remote, access that you wanted, that's why it was not available in the regular device license. For some of the tools, remote access is prohibited. So for that, we had to sign an ELA, and then we converted the device license to the named user license. So named user is to a specific user, but that has nothing to do with the server, because we have not taken any server details from you, right? So server license is something what we have is called as NUNA, that is named user network access. For example, any tools, not the Vectorcast, because Vectorcast is a floating license, but rest other tools are basically, we also have a server model, but what we call it is a named user network, so access license. So there is a server, all those licenses will be mapped in that server, but that particular user has to access the license from the server without the dependency on the hardware.
So basically, all these licenses will be installed in one server, and
Yeah.
the user, these are floating licenses basically.
The Vectorcast is a floating
license. So
yes.
if I am the user, I have to grab that license, use it on my
Yeah.
PC, and each one license will be applicable for the entire. Like for example, unit test and system test, one track, one license.
Yeah.
Is my understanding correct?
Yeah.
Yeah.
Okay.
So, software. For how much duration will I be able to get?
You will get it for 2 weeks. Again, case-to-case basis, we'll see.
I think Venkatesh, you can reply on this.
Yeah.
Can you please show us once the traceability part, like how are you tracing for each test cases, like how easy it is? Because we have, in our project, we have around 30 modules, like we have a lot of test cases.
Okay. Yeah, so here you have a test case, and we have integrated with CSV, and these are trace the test case requirements in the Vectorcast. Okay, so yeah.
Those requirement management tools we offer. So currently we have an integration with a CSV base. This is the reason because we are yet to integrate that with the doors. We don't have the doors installed in this machine, so we have taken the CSV as an option. So these are the different licenses available. The requirements available in the CSV. We use this option. We click on this option and. Yeah, so you provide the path where your .csv is. These requirements are into the local machine.
Okay.
Yeah? This can be on the doors, any requirement management tool. So we have CSV based requirements. So we kept this the path, and this is how the requirement appears here. So in this particular test case for the basis path 001, you can rename, of course. You can just right click and rename it according to your project needs. And double click on these requirements, and that will appear on the right hand side, as you can see here. So that will appear on the right hand side. And when you execute this test, case, it will appear on your full report. When you take the test view, full report, you have yeah. So these are the requirements being tested in that particular test case, basis path 001. Yeah.
So for each test case, we have to do this every time, like
each and individual test case will have the requirements enabled for you. You just need to select what requirements are being tested against which test cases.
Okay. Once you've done this, it will remains there.
Yes.
Okay, so anyway, I'll be available at the software test automation VectorCast station. So you can come back to me if there are any questions. So we will answer there. Okay. So my colleague will take on VectorCast QA, which is a system test tool. So I'm currently handing over the presentation to my.
Hello, sorry, I have one more last question.
Okay.
Can I ask?
Yeah, please go ahead.
Yeah. Nowadays, with respect to automotive, basically the development of C source code is, nobody does that. Basically, they go for this model-based development, this back-to-back testing. For example, one tool is from the other vendor, which is MC Verifier from Gaio. So like that, Vector, does it provide any tool for back-to-back testing for software?
We don't have any plugin that will take the code generated from the modeling tool or any tool and create the unit test environment. So we don't have any plugin at the moment, but we have something in the pipeline. If this particular requirement comes to us more often, maybe in future we may have that plugin. Okay, but right now.
No, sir. Basically, model-based development, there are three types of testing. Right. One, you test the model itself. So basically, you test the model based on the requirement first. And then, like when we are doing back-to-back testing, say for example, we keep, say model number 1, we keep updating the model. So we test the model based on the same requirements and compare the results with the previous test result. And next, we convert the model to C source code, execute the same set of test cases, and check whether the results are matching or not.
But that is functional testing or?
It's a functional testing, yes.
So that is possible with vector tools already, with Canoe, VTest Studio.
Yeah, that is functional, purely functional testing.
Functional testing.
But here it is like a model, you test it at the requirement level. Then say, for example, the model gets upgraded. So I'll test the same model again and to check the, if there's any impact of the update. Then I convert that model to C source code. Then I compare the results of the model test and the C source code test. And then verify the same C source code on the hardware and check the results again. This process, entire loop process is called as back-to-back testing. So there's one tool called as MC Verifier which does that, enables this process, which is from some other vendor. But does Vector provide any such kind of tool which we can use?
What we can also look at is possibly automating this entire thing with even non-vector tools and vector tools, and building this entire framework is what Vector does as a specific solution. As a project Vector takes up. So we don't have a tool, single tool as such.
Okay, understood. Thank you.
About the VectorCast new feature, that is new feature in the sense after 2021 we have a new feature, so predominantly I am focusing on that, and also I will explain the VectorCast QA feature, how it is helpful for the faster and easier regression of your system tests. See here I am first talking about the benefits of VectorCast QA. So I am quoting the current VectorCast QA features, means till 2021 I considered it current, and in 2021 afterwards I mentioned it as a new VectorCast QA feature. It's not like this year. So it is followed by one demo. I'm going to show the new feature, means previously we used to import the system test results in the ASCII format. So it is consuming more memory. Now VectorCast come up with a feature in the buffer binary in buffer format we can dump it, so it is drastically having very much less size. So it is a major advantage to save the memory. So I'm going to show you live demo on how we can whatever development environment you are using. So VectorCast QA will customize your system tests. So whatever your system test will give the results, VectorCast will import those results and show you the coverage. So I'm going to show you how exactly it is VectorCast is doing and how it is helping your to view the clear visibility of the project. This is the typical V model I have considered. The left side you can see the customer requirements, they are breaking down as per low level or system or requirements architecture level. So, which results in coding. You know, VectorCast is a tool we use for unit testing, but the QA will useful for the system testing and integration testing. Basically, actually, I can say it's a white box view. System testing usually black box, so you can view white box using the system VectorCast QA. Okay, why use it? I have these four main reasons why you should go for QA. First is test completeness. Like you have no idea whether the test is completed. Like for example, you have done unit, if you are in the bottom up approach, so you have done system level tests and other tests. So you will not be knowing whether that test is completed. So VectorCast will give that white box coverage view, so that if there is any coverage deficiency, so you can go and add a requirement, or you can even import the unit level coverage to this and view the coverage. And visibility, whatever I mentioned, is as per your standard. You can customize it and you can view that whether it is a level A or level D. So, and it is completely automatically it will detect. What I'm mentioning is automatically detect the source code changes, and it will automatically run over system tests over overnight. So it will save a lot of time. That we call it as change-based testing. Yeah, this is what exactly the VectorCast QA will do. So this is the build system. So currently, whatever build system you are having, we are not going to manipulate your system. We are just taking the inputs from your build system and the test infrastructure, whatever you are using. In the demo, I am going to show this Eclipse, the free source. I considered it as I will show in the Eclipse IDE, whatever IDE you are using. So in the test infrastructure, see, basically I considered a Lua project. I considered. So whatever infrastructure you have, VectorCast will understand. We will customize it actually. We'll support you to do that. Yeah, here you can see source code metrics from where it is getting, and code coverage data. See, source code metrics is the whatever metrics your tools is generating, we are going to import to the VectorCast QA. So, and then dashboard reporting, as my colleague Arun shown you test insights, we can push those and you view in the dashboard. Yeah, this is the conventional system testing one Python script we used to. We can fully customize it. It was not visible clear, I think. Maybe I will show in the demo how it looks. In this demo, I'm not focusing on this because it's already, maybe if you are using, you may be aware. So I'm going to focus on the whatever new feature added after 2021. Yeah, this slide I just kept it to show you. You can, if there is any coverage gap. Now, what I can say is, if there is any coverage gap, you can import the unit test results and view the whether we can stop the testing. That we can do with the VectorCast QA. Anyway, in live demo, I am going to show that also. Yeah, this is what I was referring the new feature which is implemented in 2021. See, with this, we are going to dump in binary format. Previously, we used to do it in ASCII. Maybe I can say it is I can say no other tool is doing that in importing in binary. Based on my knowledge. This is, yeah, I just taken on yeah, this is on system testing. Previously it was called vector cover. Now we have added a system testing environment window there, because we are directly importing whatever system test results into VectorCast and showing the coverage. So if you are using after 2021, you are seeing this one, this system testing environment tab in your VectorCast. Yeah, we'll move back to the demo. So I'm going to show you a Lua project, and also I'm going to practically compare the ASCII buffer versus the new Smilery small binary buffer, like how much size you can reduce. So how effective it is. Right. See, I considered I'll just make sure. Yeah. See here, I have system tests. This is system test source code actually, and I have system tests here. So in this demo, I'm going to run one of the system test. It is I already configured here through the command line. I'm going to run that literals Lua. Okay. See what exactly happening is, see if you see here, it is the instrumented just a minute. See here, this is the uninstrumented version of the file. So I'm just making sure it is building successfully. Yeah. So what I will do is, I'll make sure, just a minute. Yeah. So I'm going to save it in the ASCII format. Yeah, basically I'll just update the environment and show you. It's already, because of the time constraints, I would have shown you live, but it's already created, only will show you. See, I have used the GNU native compiler. So based on, for example, if you are using the GNU native, we have support to multiple compilers, multiple tool chains, whatever you are using. So this is I already, I used this tool chain, I'll show you. See, I have used MinGW toolchain. So the same toolchain I'm going to use. So if you, in your project, you are using whatever toolchain, we can customize and give it. No issue for that. Maybe if you need support on that. So first I will do. Here there is one option called append cover IO. In order to avoid this command line argument, there is one IO cover. You don't have to pass it through the command line. So in the GUI, we have an option to make this as append IO. So I just appended it. So first, I'm going to check whether the option is correct here. Yeah. So I'm going to instrument it now. One more thing. See, if you see the source file, I have considered the directory of the Eclipse source directory only. So whatever instrumented file which is going and dumping there only. So we have 3 options for that also. Like you can dump in the build while building, or you can just always you can we have one always you can instrument and save it. So I'll first instrument and show you. See, after 2021, it will ask you this pop-up, like it will. You don't have to create a regression script. It will automatically be saved. So the option whatever I was talking about is this one. So I mentioned it as always because I just wanted to make sure the instrumented file is coming here. See, if you see, it should come here. See, these are vectorcast added files. So I am making sure this will also, ideally it should build without errors. Okay. Yeah. So what I'll do is now, I'm using debugger to export the test results of the system test. So as I shown you, I already here I'm running this test. So see here, Vectorcast have these variables to capture the coverage. One is the coverage data pool. What it will do is it will capture the memory from where it is starting, and ASCII coverage data position. It will tell you the memory size. I will show you how it is. So because it is, I will just run with breaking points. See, memory, if you see in the right side, memory is increasing. Okay. So total 2483 bytes of memory. So I'm going to export to the Vectorcast QA now. Sorry. Yeah, from here it is started. So I'm going to export and save it in. See, save it in one binary, not binary, it is actually ASCII data. Just a minute. See, okay, I will delete all those things. Maybe I will push these are all the old data files. I don't require now. Okay. So this length 2483 bytes. You can export more memory also, but it is of no use. Yeah. So I'm exporting the complete coverage, which is getting using that literals test literals.lua. So here is the exported. See the timestamp. So this I'm going to import to the Vectorcast. just name it as one, any system test. You can name whatever this system test name is. I'll just, for simplicity, just naming it. Ideally, it should get this coverage. So this is what the VectorCast QA will do, and I'm going to show you the new feature, like after 2021. See here, I can say, because this is a simple file I used, because it may take some time. So you can see that it is 3 KB. So if you convert it into binary, it should be drastically reducing the size. I'll practically show you. So we have to, there is option in the coverage, just, yeah, tools options. So I'm going to dump it in the binary format, okay. So anyway, I'll delete this, I no longer require this one. I'll uninstrument this. Okay, so I'm re-instrumenting it. Okay, before that I'll just make sure this uninstrumented also building correctly. So this is just to make sure we are not modifying any of the source code. See here. Basically, in the binary format is going to save it in this vcast coverage bytes variable. I'll instrument and show you. You can change the instrumentation based on your needs. Actually, I have considered it as a default, like statement and branch. So based on your industry needs, you can customize it. Based on the, like, there is an option here to select your mode. So now I instrumented. So ideally it should also build successfully. So if you can see the instrumented files, you can see here. So I will just build it. So the same literal file I'm going to run. See here, this is no longer valid now. So I already added these by expressions, the watch window. Just run this. Okay. So it is actually start of this bytes. This is the memory address it is starting. And the length we are depending on the one of the .h file. I'll show you that. Okay. So here, see, as I shown you, it was previously ASCII was 2500 something. So this length we are depending on here. This according to, where is the build? It is 10th right away. See, there is one file called vcast-c options. So there are 197 bytes. You just have to export that 197 bytes. So I'll mention it as 197. see here, it is 1 KB, drastic change in that size. And I'm going to import it to VectorCast now. Okay, so next exercise, I need code just. See here, same coverage. If I can compare and see, you will get the same coverage. And one more thing is, I'll just create it, and already I'll just show that recently opened file. See here. Actually, you can add the unit test also to this one. For example, if there is any uncovered part, you can see, or if there is any deficiency in the requirement. So the entire, for example, there is one function. If you can scroll, if it is not at all exercised, or you can, if you want to cover it in unit test. So for example, here, see lua.c. This is, it is nowhere covered from the system tests. If it is if they are okay to test it in the unit level, so I'll just show you to add and the unit test, and I'll show you. Maybe based on the requirements you will add. Just I will, for the simplicity, I will just add for all the functions. Okay. Oh, it has taken close time. Okay. See here, if you go to metrics, see this luac.c is covered. No, I just maybe only one test case you may need to add, but I just showed you to confirm it is happening, and then you can push these to the test insights, whatever my friend Arun Kumar shown, and view it in the dashboard. So anyway, that you already familiar with whatever my friend shown. What? Come again? Yeah. No, we have done in the debugging. Yeah. That is actually the unit test, whatever I have considered. Yeah, it's a good catch. I'll tell you what exactly I did. See, this is the unit test. If you, the same source code I considered actually. So uninstrumented code, whatever I have built, so the same source code I consider. See, if you see the locate source files. Anyway, I will I will make sure here also I will add the same, and I will run and show you. See, so this is the path you can add. If you can add and build it, that is fine. See, I already show make sure that is uninstrumented code is already running. The same source I am using for the unit test. So I just did not run that. Yeah, and yeah, because of this time limits, I just did not run that, but the same source I considered. Okay. So next thing is interesting, like yeah, we have a we are able to integrate with the tools test. Sorry, what is that? Kenoi and test insights. Sorry, the VTest Studio. See, this we already implemented it, but currently I'm not going to show it. But definitely, if you have, I heard one of the member from there, he has some Kenoi, so VTest Studio. So see, is there is any we can give that ECU signal also to this vector cast and view. So if there is any single test, single change in the test source code, so you can run only that test case. So yeah, that's what basically change-based testing, so that you can save a lot of time. What I can tell you is VectorCast QA is a white box visibility, like you can view the results. That is what I mean. Is there, sorry. Yeah. Mm-hmm. Yes, yes.
That are going through that particular line. So it could be a unit test case, or it could be a self-authored test case, like he has shown a Lua project there. So whatever the Lua script that he ran is self-authored. It's not something VectorCast has created. Okay, so you can see that test case names being listed there. When you put your mouse on that, you can open VectorCast and you can just put a mouse pointer on any particular line and you can see the list of test cases. So here what we try to show you is that VectorCast QA is something which you can use it on your existing test jig. So your test jig could be whatever we have shown here. It could be Google test, or it could be something specifically proprietary for your testing. Okay, so you may be doing the sanity test and releasing your product. But on top of that, we can seamlessly integrate VectorCast QA, and you can get additional metrics and see, like he has tried to, like my colleagues tried to show how much coverage you can achieve. Maybe that could be one metric you would be interested on. Or if you want to ramp up on that, maybe you want to test the low-level requirements, and that's where unit testing comes into picture. So you can have the top-down approach using VectorCast QA and then doing the unit testing, achieving more coverage, or you can have the bottom-up approach. Like you can start with unit testing and use VectorCast QA. And the reason why we have shown you the ASCII data coverage and the binary data coverage is that VectorCast QA can be is optimized even for embedded applications, and the size is of importance in embedded applications. So if you have size constraints, you can even dump the binary data and get the coverage. So that's the reason we wanted to showcase that particular feature as well in this presentation.
So can I take that covered, say test case 1? What are the path covered by the test case 1? That I can get by hovering the mouse.
Right, you can.
So can I get the data extracted outside? Can I get that call graph in Excel or something? Do we have a plugin, or can I write a Python script or something to get the data out?
So you can see the coverage. It's a context switching. So you can enable one particular test case and see what are the lines of code that are getting covered. Okay.
I get that point.
Yeah.
That is all happening within the IDE.
Okay.
I don't want to use the IDE.
Okay.
So if I see what I want is, I have run the test.
Okay.
So test 1, I run it.
Okay.
I export the path covered by it into Excel.
Okay.
Or any text file.
Okay.
Say now I update the test script. I run the same code.
Okay.
Same test. Now I get the export the same coveraged path. Then I can compare whether that file is hit somewhere or not. Basically what I want is that information, I want it outside your IDE. Do we have any mechanism to do it?
Yeah, if you run that incremental build, it will show the affected test only and the report.
No, he is saying outside of VectorCast.
Outside of VectorCast, I need that information.
Then you can. Is there any export option? I may need to check it.
Modify your source code. You run the same test case, right?
Yeah.
And what you want to diff means what you want to see.
So basically, I know whether it is done or not. So I can, if I auto-generate my test cases, right? If it is not a thing, so I can take that input back, give to my automatic test case generator, and then I will put it in a loop. So my automatic test case generator can sense that what path is not covered, like whatever you are generating test right now.
Okay, one thing I want to clarify before we move further is in Vectorcast QA, we have no concept of automatically generating the test cases.
No, that my tool will do. I have a tool to do it.
Okay.
So my tool generates 4 test cases for a condition.
Okay.
Now I run it.
Okay.
I got the coverage gap from that.
Okay.
Then I want to know where the coverage gap is exactly in this one.
Okay.
So I can run twice and take the difference. That difference I will feed to my tool, my test generation tool. That will create an effective test case that it will cover the uncovered path. You are getting my point?
No,
that
there are two things here.
Not possible.
One thing is that whatever the data that gets generated within Vectorcast, right? So that data is something is based on where we instrument the source code. Okay, and the first data that the raw data you are importing into the Vectorcast QA project, and then you will get the coverage. Okay, and next thing is you can export it like a HTML report or a plain, not a plain text, but a HTML report. Maybe you can do some kind of scrapping on top of that and build it. But inherent in Vectorcast, that is not there. Okay.
Okay. Now that export option, you have only a HTML. Right?
Yes. You can have the coverage viewer. You can have it context switching also. Per test case also you can have it, the HTML report.
Okay. So do we have any other exporter? Can we write our own exporter? Because I know most of the tool provides HTML, but when I get the code coverage gaps, I am not going to give justification in HTML. I need that in Excel. Right now we are scrapping from HTML. Whether do we have any extractor or any other tools?
See, basically that is not the motivation of the tool. The tool will give you the ways to easily achieve the your testing targets. For example, here let us say coverage. So if you are not able to get the coverage at the system level, you can import this coverage to the unit level. Okay, and then you can start from where you left off. It could be automatic test cases or it could be manual test cases. Ultimately, you can achieve 100% coverage. That capability is there in the tool. But whether you want to benchmark them and then feed this to a third party, whatever the proprietary tool, and the tool can understand and generate another test case, run it, that is not, I believe that is not the domain of our Vectorcast tool.
No, that I understand.
Yeah.
I want more help from the tool so that my work also get reduced.
Maybe we can have this discussion offline and take it further. Yeah.
Okay.
Right.
This is the last session for today. Thank you for all your time. I'm just saying thank you and starting this session. This is SCORE, and this is an engineering analytics tool. It is basically, it compiles multiple sources, multi-source data, and creates dashboards for 3 different purposes. Mainly, first thing is project management, and second thing is process compliance, and other thing is standard compliance. Like standard compliance in the sense, if you are following some standard like ISO 26262, then for the compliance of that, you can use this tool easily, and any auditing or anything. This even generates documentation as well based on how you configure the tool. Like a report to a safety engineer you have to send for audit. This tool will generate for you based on how you configure the tool. And for process compliance, it even helps you for if you have any ASPICE audits or anything like that. For it helps in tracking all the documentation. That is also possible. So let's start with it. So today I am going to just show this tool, how it is going to, as the theme is technical debt, how this tool is one of the solutions or one of the tools that can be used for addressing technical debt issue. Okay. Okay. So basically, it is a monitoring solution for engineering. There are other tools as well in the market which create dashboards and stuff, but this is mainly for engineering solutions. So this is created in the view of all the engineering problems that happen. Okay, the KPIs, it follows a model called SCALE, software quality assessment based on life cycle expectancy. So it is like, this is a model that is created. This is an open model that is that can be used by all the tool generators. So that is the background of this tool. This uses one of that method. Though that scale pyramid is one of the methods used mainly for addressing technical debt. That is one of the metrics. So what is the key feature of this? So it acts like an aggregator where it takes data from multiple data sources. So we can configure the data sources, like it can be your Excel sheet, it can be your IBM Jazz, or it can be your Jira, and anything from requirements management and your test environment. Say you are using Kanu and you are using PCLint plus Vectorcast. All the things you can use this as data inputting for this. And combinedly it will create the metrics for what is the debt in the system, what is the technical debt in the system, and it will give the metrics in man hours. So to refactor this thing, how many man hours you need to spend on this, it will be giving. So, and the metrics works in a rating kind, and we can create a quality gate for it. Say for example, you have some requirement that is modified and the test case is not updated. So it will throw a flag saying the requirement is modified, but the corresponding test case is not updated. So this kind of things, this can be a simple thing in a standalone project, but where it is a distributed and multiple teams are working across time zones, this is a very good indicator. In such a flagging situation, we can work on it. Okay, and it is very easy to use, and it is an interactive dashboard. You can configure your own metrics. We will help you out with that as well. If you have any organizational metrics you want it to be used in these dashboards, that also can be configured. As I said, it generates the reports. It even generates, say, project management, PPTs also it generates for like status reports or something like that. So coming to why you have to use SCORE as one of the tool for technical debt. There are many tools that we talked till now. So why you have to use? As all the metrics, like you are working on multiple tools, and you don't you have to manually get the reports, and you have to compile them and create the debt, create the what is the issues and what is all pending items, and you have to manually plan for the refactoring as well. But SCORE will help you out in reducing this thing, and code review costs also will drastically come down. So, and early detection of bugs will, as every one of you know, that early detection of bug is less costly. So this SCORE tool will help you in that. Okay, and this is mainly for decision making. You can use this for. Yeah. So coming to this, you can say this as USPs. It is very easy to use, and as it is like having very only dashboards and stuff, and it is reconfigurable as per your metrics. So it is easy to use and easy to deploy. And even in a pipeline, if you want to use it, most of the tools expect you to know certain command line features and things. But SCORE will generate even the command line, that command that you need to use for integrating this as well. That also, the command also it will give you. You have to just copy and paste it in Jenkins environment or whichever environment you are willing to integrate it. So this is the scale pyramid. So software quality assessment based on life cycle expectancy. Okay, this is the scale pyramid. So this pyramid represent the distribution of technical debt based on like where each project is sitting and which part of life cycle it is. And say for example, if a project is completed as per expectation, but the quality is not as expected. Say 10 man hours, just for example, 10 man hours has been assigned for a task, and 10 man hours, within 10 man hours the task is completed, but the task comes back again. So no one is tracking this, this wastage of budget here, and the reversal is not possible to track. So scale pyramid helps you in tracking that. So once you complete the task, and the quality metrics is available from different data source, the quality metric will be available from different data source, and that will be mapped together and shown in the single dashboard. So where is the wastage and how much is the wastage? So you can track for the future applications. So again, if there are multiple projects, similar projects, you can compare the distribution of this is one such representation. Again, this representation we can change as per the convenience of the engineering team that is using. So if multiple projects are there, based on the variance, each project will be depicted, like which is the better project that is running also, you can have a view. So any learnings from the better doing project you can incorporate, because all the dashboards, all the data is available at the single place. You can have the learning and management also will be easy. So this is the man hours data I was talking about. So what is the technical debt, and what is how many man hours it need, and again how is the performance going on, what is the variation, all these things will be available in single place. So, and based on the current project execution and how it is going, there will be planned, like you might have seen this in other tools as well, because nowadays it is frequent, one of the frequent metrics to show what is the change in current prediction. So this one, the difference here is the metrics is captured based on multiple data sources. So that this metrics has been said to us that it is nearly accurate. This is claimed by some customers to us. So this is how we can configure, like technical debt, objective plan, and what is the how the plan is going on. All these things we can see here, and it will throw certain automated action plans to us, like where we can concentrate and which parts, like which components we can concentrate to change, and which components we can refer, and like say some critical components we need to keep an eye on. So that also we can configure here, and those components we can define a separate matrix. So that all it will show as automated action plan. So this thing we can so we can select the filter and say this C function you have to implement because of this matrix. Say his matrix is what you are following. Because of this thing, you have to change this C function before it reaches this part of the life cycle execution. So this is what all tools we can integrate with it. As of now, we have 50 data sources that have been configured for SCORE. You can have Git, SVN for repositories, and you can have Vectorcast, and you can have PCLint Plus, even other tools as well, Clockwork, and whichever if you are using. And for ACM tools, you can use ClearCase, Git, SVN. And again, requirement management, there is a vast requirements management support, Doors, Polarian, Jira, Jama. So all these things are supported. Okay. So requirements to test case. In a single dashboard, you can find out requirements to test case, everything you can find out in a single dashboard, and you can traverse along multiple versions as well. say you have 5 different versions with each having 10 minor versions. So that comes out to be like 50 versions, and all the 50 versions you can traverse for each thing. Say, what is the use of it? If you ask, what is the use? Everything should have some use, right? So use of it is like, you can see if any particular component or a particular test scenario is failing multiple times over multiple cycles. So that metrics will be available for you before in the dashboard itself. So you can concentrate on changing that component because it is failing multiple times and giving trouble over the period of time. So that can be concentrated. So that is one thing. And the KPIs are mostly tailored to the industry. So if you are looking for some tool that you need to start working from very soon, like you want to deploy it, the learning curve should be less, and you want to start working in 2-3 days. So this is one of that kind of tool where the KPIs are already tailored to industry needs. So there is not much needed unless you want it to be. So this is again how on top of Vectorcast, if it is used, how it will help you. So Vectorcast coverage metrics it is taken, and single dashboard if you want to see which one, like you can traverse from this graph as well. From here you can see what is the percentage, everything. But when you are seeing a overall picture for an multiple teams or in single team or in a platform level, when you are seeing, it is better to have in that way than to have gobbled up with multiple numbers and confusing stuff. So the graphs give us picture like which level has more problems, or which project has more problems. Those things are clearly visible. So next, why do we use it? So what is the need of using it? There is this tool provides you access to multiple data sources in a single place. So if this is not there, what you would be doing most probably is capturing the data manually and creating Excel dashboard and editing the dashboard as and when the metrics is changing. And you have to have a dedicated team if you are capturing this and creating the documentation. You have to track that over the versions. And the same knowledge that you have accumulated in one project, that is not easily traversable to other projects. So this is not the scenario. Everything it tracks in the single place, and we can create role-based access to users. So you can create your own dashboard that you want to view, which is relevant to you, and each user can change what, like each user can be assigned with certain data what they have to see. Yeah, and again code quality solution. So out of all the tools that are available in market now, Java and Python are also started to come up well. If you see some of the tools, multilingual support is needed. Some of the parts like Python is used, but you don't have a tool to analyze that Python quality or Java quality. Score will help you to an extent, will not help you extensively, but it will help you if the code repository is limited. And basically you are an engineering team working mainly on C and C++, but you have a little bit of Java and Python code as well. Then you can use the help of it to analyze that code and bring up the metrics in single place. So, and VNV framework. So where does this fit? How to use the most benefit of this tool? The best benefit of this tool is used when it is integrated in CI/CD pipeline, and where the data is coming from multiple sources, and it is gradually streamlined and then continuously used. That is where the most benefit you get when you use Core. And maturity level, this can be used like an indicator, like what is the maturity of the software. This is one of the indicators that is available. So where is our software currently standing, that you will have. So to go back and work on it, the metrics, this metric will help you. Okay, and this one I have covered. It is like you can create a standardized way for reporting, and if you are sending for an auditing purpose, you have to send some documentation. Instead of preparing yourself, you can configure the tool. It will generate the document for you, either in PDF format or PPT format, and you can send it across. As this is tool generated documentation, it will be in whatever format you have designed. So proof checking is not needed. So you can concentrate on your engineering tasks than the supplementary tasks. Okay, this is based on this slide is compilation of how the current users of this tool are using it. As I said, they are using it in CI environment, and it is used like this. This is you might have seen the Blue Ocean screenshot is that. So start, it is like static analysis, and then unit testing, and then integration testing. Score comes, and it will have something called process gates. We can define this quality gate, or you can use the existing one that is tailored for the industry. So there is no new finding, or new function must have test, something like that. You will decide the quality gate. One of the quality gate that that we have experience with, we have seen with the users is the quality gate for any updates in the requirements, the test cases has to be updated. That is one of the quality gate. So requirements to test case across the levels. And you can have multiple quality gates as well. And other than quality gates, you can define reliability gates and whatever you want to define as per your team working structure or your organizational metrics. So this is one of the how it is used. And there are few users who use it manually. They don't want this stuff. But they have large amounts of data that is being generated. So they want to just have the automated dashboard. They want to generate that and check how it is working on for their project. So that also can be used. So that is based on how you want to use it. So that's it about the tool. Any questions? Yes, yes. The metrics
Suggestions
definition
are shown,
is that way. Suggestion is there. If you see the previous slide, which this is automated action plan.
Okay.
This automated action plan will give you, like we have to configure it based on your need. Automated action plan will give you what to do and which part of the life cycle you have to do it. So you can keep the track of it as well. And this metrics will give you exact amount of man hours needed for that task completion as well. So if you take this metric, if you use this metric, there are hundreds of dashboards. We will configure. We won't be using everything, right? So whichever is relevant for you, we can configure. You can configure and have it. It's all easily configurable.
Got it. Thanks.
Maturity and all that.
Hello. Okay.
One slide at the start. Yeah, this is good enough an example where you have dark blue and light blue stuff, right? How to read this?
Version 1, version 2, version 3, like that each version of each
No, no, I'm talking about the bottom one, not the top.
Oh. Hello. So, based on that, if you see here, here you are getting that how many hours, man hours has to be spent to achieve this objective. Like the testability, there is certain thing that is designated. This is based on a sample project for the user that we had. So this is based on a demo project. We can again reconfigure metrics that is having. So this is all configurable stuff.
Okay, thanks.
This tool will generate the report for the audit. So this tool will generate the report for the ASPICE assessment.
Yes, we have currently one user who is using for a ASPICE audit, and as they have completed their ASPICE audit successfully, so we believe the reports are
So it will follow the level wise, level 1, level 2. Or
Yes.
do you have any such an example?
I don't have it in the slides, as this is catered for generic slides. I didn't.
Okay.
Yeah.
Where we coverage tool or something like that, where we stitch all the CVR files to get the aggregate coverage report. So what is the difference between the test insights and the coverage?
Test Insights is actual testing tool, actual testing plugin, we can say. User will be having the Test Insights configured. The user will be working on some test cases, right? They will push the data to the cloud via Test Insights. That is how Test Insights work. So that is only for Vectorcast. This is an analytics tool, basically for data crunching and creating giving you some designated intuitive like suggestions, and again to work on the current project. So this is the idea of this tool. So both are different. That is for actual testing. So you can't do actual testing on this. This can generate like code quality metrics, and it can do static analysis. This can do, but the method it follows is different.
Thank you.
Over here for being so patient, and we are thankful for all the questions that we have got. I would request you have the feedback forms or the contact forms available. So if you have anything that you would want to mention over there, anything that you need our support with, we'll be happy to support you with that. You can just fill those up and keep it on the desk. Someone from Vector will pick it up. Though the sessions have ended, you still have the opportunity. We'll be available for a while. All the technical team members, you've got the demo areas behind you. So feel free to go and check the functionality. If there's anything specific you would want to discuss, this is the time. We are available here for you. And once again, thank you from all of us.
Thank you so much for giving your take for us, sharing it with us. Please, if you want a
Yes, so the demo area behind is available. It's available outside as well. So you can just pick up a cup of coffee and come back inside, have a look at the demos. So everyone from Vector is available over here. Thank you. Thank you, everyone.
Hare Krishna.
By looking at connect you with him, and then he can give you a call. Yeah, and he is quite very versed in the whole capturing of No, this is not feedback room. This is to capture any of the queries that you have. So I extend this out to Mohammed so that not which no, I will you got to write it. In this VectorCast QA, VectorCast QA will be helpful. What this VectorCast QA will do is that it will be part of, we have a concept of something but instrumentation. So it will take your C code, whatever is running on the internet, it will instrument the C code. Now what is it? So that it will have an intelligence to capture the metrics. The metrics will be statement, branch and MCDs. Apart from that, if you want to pass some real-time data on outside world, you can even have some kind of log messages added as part of instrumentation. This is what basically instrumentation is. After that, it is all the same. You will build it, you will run it on your target. Once you run it, you will use the Python script on top of plan how to automate. Write it down. Okay, so VectorCast is so flexible. Great flexibility in terms of great problems, right? We have to chart out a plan how to automate. Even let us say that we could not automate. Even that gets like coverage. Again, with the project, that is another way. And what is the name of the execution? Line number 38. Name of the variable, that is the name of the binary. That is what. And then line number 40.
Directly want to use the system. Then you can send me the Thank He is the one who taught me, so whatever he says,